Okay, I'm going to try this again. You don't have to feel sorry for me, but I just went through this entire video once, narrating it like a boss, and got to the end, went to click stop, and never really started. So this is the introduction to confidence intervals for one proportion. This is section 8.2. Again, these are the visuals from Mr. G. You can hear his narration by clicking up above, but this is me, my voice with his visuals. This is the way I would explain things. This video mine will be a little bit shorter. His is 13 minutes or whatever. This one won't be as long because I'm going to cut out some of the stuff that he talks about. But so here we go. Now, we talked about what a confidence interval is. CI, right? That's the cool way to say it. It's made up of two things, three things, depending on how you say it. It starts with a point estimate. That point estimate is a statistic. It came from a sample. It was either an X bar, that'll be 8.3, or a P hat, that'll be 8.2, right? It's one of those two things. But you go, wait a second, I can't just say, I think this is it for the whole population. So we build this thing called a margin of error. And then we use that to say, hey, I bet you the real mean is between here and here. Or I bet you the real proportion is between here and here. That's built around that X bar, that P hat. Now, we're going to get into the formal definition. That's statistic. Remember, your X bar or your P hat. The margin of error is actually, it's not just, you can't just say, hey, you know what, I'm going to go plus or minus 3. I'm going to go plus or minus 5. That margin of error is actually made up of two things. One is called the critical value. One is called the standard error of the statistic. Both of those will be familiar. We're going to put them together. This isn't just, again, hey, I want to pick my margin of error. It's calculated. This section, 8.2 and 8.3, are partially about where does that come from? How do we build this whole confidence interval in a way that that has a reasonable margin of error and it actually makes sense and it can be actually accurate and reliable? Okay, so after the plus or minus, right? Statistic plus or minus margin of error. That margin of error is actually made up of two things, right? The first thing is the critical value, and even though it's first, it's going to be the second thing that we talk about. The second part of it is called the standard error of the statistic. Standard error of the statistic is happy cool stat talk for the standard deviation that you knew from back in chapter 7. If we're talking about the standard deviation of all the possible X bars, that's sigma over the square root of n. This was from section 7.3. If we're talking about the standard deviation of all the p hats, this is from section 7.2, it's the square root of, wait a minute, it was p times 1 minus p over n. Notice it's now p hat, right? It's called the standard error of the statistic because we're building it around the statistic. And so, because we don't know p, it wouldn't make sense for us to try to use a p that we don't know. That's why we're doing this confidence interval, to estimate the real p or the real X bar. So since we're working with p hat, this is going to be p hat in this formula. It's the same standard deviation formula that we used in the last chapter for proportions or for means, except now it's going to be part of our margin of error. It's called the standard error of the statistic. Okay, so here's in all its glory. This is what a confidence interval for one proportion looks like. We went out and we took one p hat. We found a statistic. That was a p hat. Plus or minus. These two things together are the margin of error. The critical value, most people say it z star. It's like a z-score. Except I think it's cool to say it like French, z star. It makes it way more fun and it's way more cool. And then the standard error of the statistic, the formula for standard deviation for the sampling distribution of all the p hats, square root of p hat times 1 minus p hat over n. Again, these two things, the critical value, z star, and the standard error of the statistic, square root of, those two things form the margin of error. So here it is in just another little picture. Now he hops back and forth here. It bugs me a little. There it goes. Confidence interval, statistic plus or minus critical value, z star, times standard deviation of the statistic. Now, standard deviation of the statistic depends on which statistic you're working with. If you're working with means, you know, X bars, you got this going on. If the statistic you're working on is proportions, you know, p hats, then you've got this standard deviation of the statistic, right? The formula that you use depends on which situation you're in. Are you in means or are you in proportions? These are the formulas you've worked with before. Now he's going to add a hat on these because it's not there. We need to have that p hat in this formula, but it's the same formula you've worked with before. It's just that the proportion that we're working with is the one from our sample, so it's a p hat, not a p. If standard deviation of all the x bars is this, standard deviation of all the p hats is this, add the p hat. Now, Mr. G, come on, you can do it. There you go. Good work. Thank you. Conditions. Now, what he's saying right now is, hey, you guys can read. So what I'm going to tell you is, hey, you guys can read, but here's the reminder. 3 conditions that you're going to have to check every single time. First and foremost, it has to be random. If your sample wasn't random in the first place, you can't do it. Right? The next 2 things, independence and normality. Independence is the 10% condition. That gives us permission to use the standard deviation formula that we're using. 10% meaning little n, sample size, less than or equal to 10% of the population. He says 10 times the sample size equals the population. Same thing. And then normality, n times p and n times 1 minus p. Notice p hats. If those are both bigger than 10, we're good to go on proportions. Different checks for means, we'll talk about those later. The last part here has to do with the calculation of z star, the critical value. I will tell you right now, you will not have to calculate any critical values, but I do want you to have awareness. So it's all built around at least the general idea of the good old 68, 95, 99.7 rule, which says if you start at the mean and you go out 1 standard deviation, you capture about 68% of the values. If you go out 2 standard deviations, it's about 95% of the values. And if you go out 3 standard deviations, it's about 99.7% of the values, right? So it's built around that. How many standard deviations? That's what z star is. If you wanted to be 68% confident, no, you always want to be more than 68% confident. But since we know the 68, 95, 99.7 rule, he's going to start here, right? If you wanted to be 68% confident, your margin of error would need to include a critical value of about 1. He's talking here about how that's calculated more specifically. Not just about 1, but could we calculate it exactly? 68% of the values are within 1 standard deviation of the mean. So this is saying, how much is in this tail down here? He's going to circle it here in a second. How much is in that tail? If 68% is between these lines in the shaded part, that means there's 32% in the 2 tails together, which means this is 16% down here. Watch, he's going to do the calculations about how to get there. 100% is under the curve. Take away the 68% that's in the shaded part, that would be 32. But we only want this half, so divide it by 2. This part down here has got to be 16%. 16% of the values are in that part of the tail. So where would we have to go to capture to have 16% down there on your calculator? And again, you won't have to do this again. If we were all together, we would spend some time doing it, but you did it back in chapter 2. Good old inverse norm on your calculator. Inverse norm was 16% with a mean of 1 and a standard deviation, a mean of 0 and a standard deviation of 1 because it's a standard normal curve. We know this should end up being about 1, right? It should, because the 68, 99.7 rule. If you do inverse norm using 0.16 and a mean of 0 and a standard deviation of 1, magically, come on, Mr. G, and that turns out to be 0.99. 0.99 is darn near 1, right? It says if we go out 0.99 standard deviations, if we picked a critical value, z star, of 0.99, we would be making a confidence interval that is 68% confident. It would capture about 68% of the values in between there, right? Again, you would never go with that low of a confidence level, right? But the process is the same. If you want 90%, how much is in this tail right down here? 10% in the 2 tails, half of that is 5. Inverse norm using 0.05, it tells you this should be more than 1 standard deviation, but not quite 2. How about 1.645? Z star for 90% would be 1.645. Inverse norm, where would I have to go to capture 90%? To do 95%, same game. Now this one should be darn near 2, right? We know that. 95% of the value should be within 2 standard deviations. Here's what Mr. G says. 0.95 is in there. That means there's 5% in the 2 tails. Divide that by 2. This is 0.025. Boom. inverse norm with 0.025 should be 2, right? Oh, 1.96. Really, it's not 68, 95, 99.7. Okay, it's not 1, 2, and 3. It's 0.99, 1.96, and something. 1.96 is the critical value, Z star, for a 95%. You want a 99% confidence interval? That's 0.05. Inverse norm says this should be more than 2 standard deviations, but not 3, 2.576. 99.7? Hey, this one should be pretty dang close to 3, right? 3 standard deviations should capture 99.7% of the values. He's saying these are the 3 probably most common ones that you'll work with right now. And if you know those 3 critical Z stars, you would be in good shape. The truth is, as I said before, because we aren't covering every single thing in as great of detail, you won't have to calculate those. I want you to know where they're coming from. For 99.7, there's 0.03 between the 2 tails. Divide that 0.0015. Inverse norm, 0.0015. This should be 3. Oop, 2.968. 2.968. 2.968 standard deviations from the mean gets you 99.7% of the values. What he's going to talk about next is how you can do it for any value. It's always 1 minus the confidence level, divided by 2, do the inverse norm of that, and it will always tell you what critical value would be needed. Again, you won't have to do that. I want you to have awareness that when we talk about critical value, Z star, it's saying how many standard deviations. Do I go out 1 standard deviation? Do I go out 2 standard deviations? 3? Somewhere between there? How many standard deviations do I go to capture the level of certainty that your boss or whoever tells you they want in your confidence interval? Then we multiply that by the standard error, that formula that we know, square root of p hat times 1 minus p hat all over n. There is your margin of error. Okay, that's it for this video. There will be more coming in the other one, but we're going to stop right there.